Building AI agents is a very difficult task, complicated in so many ways. Anthropic dropped an amazing tutorial, an amazing guide a few weeks ago entitled Building Effective Agents. So that's what we're going to be doing in this video, where I'm going to dissect their views on how to build effective agents and agentics workflows. One other thing that is very subtle that I want you to pick up here is that if Anthropic is talking about agents, that goes back to tell you that agents is the thing you need to focus on moving forward, at least 2025 and beyond. So this is a gold mine here. First thing we need to look at is understanding exactly what is an agent. So there are many definitions here. By the way, Anthropic, if you don't know who and what they are the builders or the creators of many large language models that we use, such as Claude. So they know what they're talking about. The first thing you can see here they do is to define what are agents. Now, understanding what an agent is, it also comes with certain nuances depending on which industry you're in. But at the end of the day, they kind of summarize and divided the definition essentially of agents in two parts. They say that everything we consider as agents, AI agents in this case, which are tools that are capable of doing things more than what a large language model can do, which means they can call different tools, different functions, different things that they can call to help get to the right result. But on top of that, an agent can also be autonomous, which means it can take a question, a query, and autonomously create some sort of orchestration where it can call other tools as well as calling other agents in a system, agentic system, to get to the right result. Okay, so that is the concept, overall concept of an agent. They go further into categorizing here. It says we categorize all these variations as agentic systems, but we draw an important architectural distinction between the workflows and agents. So what are workflows? So what they're saying here, workflows have a predefined code paths. What does that mean? Well, it means that workflows will have what needs to happen next, because there's this sort of orchestration of tasks that need to be done, needs to be happening in order to have a full-on system of agents that interact with each other. And in this case, also the agent itself, on the other hand, as they say here, these are systems where large language models dynamically direct their own processes and tools. So we talked about this automation, autonomous side of things when we talk about agents. So they're differentiating workflows versus agents. And they go ahead and talk about when and when not to use agents. I find this part particularly important because, especially if you're still in the beginning stages, it's easy to just go with the buzzwords, agents. So we think that everything has to be an agent when we're building our systems. So they say here, when building applications with large language models, we recommend finding the simplest solution possible. And this is always the case. Do not overcomplicate things. If you want to build an AI tool or solve a problem with AI, you have to always think about what is the simplest way for me to build or solve this problem. Does that mean that you have to right away go and find a framework, go and find, start creating agents to solve a simple problem? The reason why is because when we talk about agents, we have some trade-offs. Right? It says here, agentic systems often trade latency, which means it takes time for the process to happen of the data, of the queries, of the things that we're asking the system to do, because it has to go and talk with other agents in this system. So it takes time to get to a result. And also cost for better task performance. And you should consider, as they say here, when this trade-off makes sense. Okay, so they don't talk too much about it, but it's a very important concept. Speaking of building effective AI agents, effective systems, this brings me to today's sponsor, Brilliant. You know what's fascinating? While I was breaking down this AI agents concept here, I couldn't help realizing quickly how similar Brilliant's approach to AI is to how AI agents actually work, because it's all about breaking down these large complex problems into manageable interactive steps. Brilliant is where you learn by doing. This is why I love it, because you have thousands of interactive lessons in math, data analysis, programming, and AI. Now, what I particularly love about Brilliant is their AI courses, including their new How LLMs Work course, which perfectly complements what we are discussing today. Instead of just watching lectures that never end, as we all know, you are actually solving interactive problems that help you truly understand what's going on. The platform is designed by experts from MIT, Caltech, and Google. Yes, very smart people, which makes this tool the perfect way to build the foundation you need to understand and work with AI systems like the ones we're discussing today. If you really want to understand how things work in many different disciplines, including AI, check out the link in the description. The folks from Brilliant were kind enough to give all of you guys a 30-day free trial plus 20% off an annual premium subscription plan. Go ahead and check it out in the descriptions below. Back to what we were talking about here, you can see we have this when and how to use frameworks. The team here talks about that we have so many frameworks out there and many more that will pop up in the next months and years and so forth. But the key point here is that they focus should never be on mastering one tool, or in this case, one framework, because frameworks change. And so they have LangChain from LangChain, or LangGraph, I should say, from LangChain, Amazon Bedrock's AI agent framework you can use, Rivet, and Vellum. So they don't spend too much time talking about that, and they say these frameworks make it easy to get started by simplifying standard low-level tasks like calling LLMs and so forth. Okay, so says here, however, they often create extra layers. This is the problem. Most of these frameworks, as amazing that they are, remember, they will always abstract out the underlying systems that are happening, which is good because we don't have to think about those underlying systems. But also that means we have more complexity that we're adding into our system, our AI agent. It's something to keep in mind. They say here that we suggest the developers start by using LLM APIs directly. Many patterns can be implemented in just a few lines of code. Again, we go back to simplify things. If you want to build something, make sure to simplify the process first. Start small. Don't try to get all of these different tools. All right, so then they go into the meat. So they start by looking at the building block, first one, which is the augmented LLM. What is that? Well, augmented LLM, they do have here a diagram. So what that means is that we have an input, we have the output, and between that we have the large language model. So for the base large language model here, we have a few things that are not being shown here, but the idea is that we have core reasoning capabilities that most large language models have, and we have natural language understanding. Of course, those are the things that it has already. Most large language models do have that. And of course, task processing, that's one of the other things. But then we have something else attached to them. That's why we call augmented LLM. So we have retrieval, we have tools, and memory. What is this? Well, retrieval allows us to access external information. So that's when we talk about RAG systems, for instance. Okay? So the idea is that we could have retrieving these tools being able to retrieve, in this case, different pieces of documents in a RAG system, so that it not only is going to be able to have its knowledge base, I should say, but it can also query other documents that we ingest or inject onto this large language model. Again, this allows for accessing external information, also knowledge-based integration, because we're integrating different knowledge bases in terms of database. Could be a database, CSV file, documents of different formats. Then we have these tools, which is tool usage. This is very important, as any large language models, as soon as we are able to call a tool, it becomes more or less an agent. So the idea, we have call and response here. So we can call a tool, for instance, an API integration, external service integration, system commands, what have you. And so this symbiosis that we have here is that now we can call these tools, API, external services, system commands, and get response and bring it back to the large language model as the main hub, which can then process that information and then send the response. Now, the next part here is memory. Memory is very important because this is what keeps the context, the contextual meaning of what's happening in a conversation, because large language models usually on their own, they don't have memory. So in this case, we're able to write and read pieces of information that are contextual for the situation. You can imagine having, for instance, a conversation history that is needed in a chatbot that is being that has a large language model attached to it. Task state tracking, context management. This is what we call the augmented large language model, and most of you have seen something like this as an agent. So these are the three pieces that an agent, a good agent, should have. The augmented LLM. And they talk about the recommendation, essentially implementation strategy. So basically what we're talking about here is to focus on use case specifics, okay? And make sure that you have clear tool documentation so we know how these tools are being used, what kind of tools are needed, as well as make it simple with well-defined interfaces and error handling protocols and so forth. And they give an example here of an implementation of the model context protocol, as they say, which allows developers to integrate with growing ecosystem of third-party tools with simple client implementation. So this model context protocol is beyond the scope of this video, but you can check it out later. So the idea is that we are adding something to this large language model, which means we're augmenting its capability. They talk about workflow, the prompt chaining. What is prompt chaining? The first concept of prompt chaining is the concept of sequential LLM calls, as I will show you in a diagram here. So essentially, you will see if I go down here, we have the input that comes in, and we have the first LLM that is called, and then that output from that is going to be passed along. Now we can also add what we call the gate to say, okay, if something goes wrong, it's going to fail or pass. If it passes, we continue on our chain here. Okay, so each time we are chaining things, going through each step process previous, where each step process previous output, as you see here. We have this and get the output. We pass through, if need be, a gate. So essentially a place where it can gauge to make sure if the information that was returned by this call, LM call, is correct. If it fails, then we exit, the process is done. If not, then we go to take that response, the output, and pass to the next large language model and to the next, and then we get the output. Now, when is this useful? When is this prompt chaining workflow useful? Well, this is useful in cases where we have very complex tasks that need to be broken down into simpler or smaller pieces, okay, to manage them better. They talk about examples where prompt chaining is useful, for instance, generating marketing copy, then translating that copy into different languages. Makes sense, because translating is not a simple task, it's a multi-level, I would say, task, multi-step task. So using, in this case, this concept, this workflow prompt chaining in these kind of cases, when one generate copy, marketing copy, and translate that into different languages, will be really good candidate for that. Also, they talk about writing an outline of a document, checking that the outlines meets criteria, certain criteria. And next, they talk about routing in a workflow. What is this? So what happens is we have the input that comes in, and we have a central large language model, which is going to be the router. The router means it's going to know how to orchestrate where things have to go. So the idea here is that first is going to know what task it is. So essentially, it's going to classify and delegate. That's what this router does. We'll classify whatever comes in, and it's going to delegate to say, okay, this is going to go to large language call 1 and go straight to output, or if something else is going to go to this call here, large language model, and something else goes to this route here. That's why we call it the router. So you can think of it as an orchestrator of sorts, because it's able to orchestrate by getting the input and then classify what this input is all about, and then start delegating. A good use case for this would be, for instance, if you have customer service query sorting. So if you have a system that deals with customer service queries that are coming in, you can have, in this case, a routing workflow depending on the different queries that are coming from the customers. Then you can route them to the appropriate large language model where they can handle those cases. Next one is the parallelization. It means that we have things going in parallel. So we have input here, as the diagram says. In parallel, we can have the call 1, 2, and 3. And then at the end here, or in the middle, I would say, we have, yes, the aggregator. So the aggregator is going to aggregate all of the results that will run in parallel and then maybe do something else, right, to aggregate everything and maybe create a summary or whatever needs to be done, and then return that result, the output. Here are some examples when parallelization is useful. They call it sectioning. So what does that mean? Well, sectioning is breaking into smaller tasks, essentially, okay, as they are explaining here. So we're breaking into parallel substacks. And then the voting side of thing, as an example of this method here, is reviewing a piece of code, for example, for vulnerabilities. We'll be having multiple attempts for better results. So if you're writing code or you have a large language model that all it does is writing code, I should say, if you have a system, agentic system that writes code, helps you write code, well, if you ask it to write a certain piece of code, you want to make sure that it's able to think through first, but also make sure to have multiple attempts until it gets it right. Because sometimes the first draft, if you will, is not going to get you the right results. So that is essentially what voting in this case is. Let's go to orchestrator workers. Here we have the orchestrator, right, which is going to orchestrate everything. So we have the orchestrator and we have the actual workers that will take information and, in this case, synthesize and do things that needs to be done to get the final result. So essentially, what is this orchestrator workers workflow? Well, so essentially we have the central AI, which is going to coordinate specialized workers. So these would be the workers. But how does that work? Well, there's this dynamic breakdown and delegation process. It takes in the information, the query, the input, and then breaks everything down and delegate for each one of these workers. And then at the end, we have a synthesizer. Because it has to synthesize all of the results that we get here to then pass through the final results. So when would you want to use such thing? A good example would be for complex projects that need flexible coordination. And they have these coding products that makes complex changes to multiple files each time, as an example. Because you would need different workers that will do different things. And then at the end, we'll have a synthesizer that will make sure, for instance, in this example, that this code actually works before we pass it out as a final result. And next, they talk about the evaluator optimizer. What is this? Well, this is what we call the feedback loop system. Because you can see here, we have the input and we have the call, the generator LLM. What this does, well, it goes ahead and takes that input, and if there's a solution, sends that to an evaluator large language model, and if all is good, it goes ahead and is accepted, then we have the result. If not, then that is rejected. But the most important thing here is that it's rejected, but it gives the feedback of why that was rejected, which is really important because now we have this feedback loop that goes around with data. So not just rejected, why it was rejected back to the generator. The system is very important because one AI evaluates another's work. So when you want to use something like that, so we can see there are many use cases, but one of the main cases when you want to use this would be if you have a system that needs quality control. That is very crucial to have this quality control. Obviously, this would be the best workflow that you can use for that. Okay, and they talk about that as well here. Now, let me talk about some key concepts that you need to think about in this just as an overview. The first thing is design principles. One is, as a design principle, is to keep simple. Don't try to reinvent the wheel, but also don't add complexity when you don't need complexity. Don't go and start using different frameworks out there when all you can do actually is just do API calls on an LLM out there and get the job done. Number two is to make it transparent. Make sure that when you create these agents or use these large language models, make sure there's some sort of transparency around it. Also, most importantly, these large language models, when you're creating these agents, creating these workflows, make sure that they are focused on reliability. Reliable large language models is what you need to be able to build effective agents. And the rest of this blog post talks about agents, what we've talked about and defined earlier, but they go into a little bit more detail, and it's worth to read it. Right? So they have, of course, this very nice diagram here. And I like this because it adds this another component here. And this is what we call autonomous agent. The idea is that we have the large language model call, but it's autonomous, which means it can actually work on its own because it has all of the pieces that it needs to run and do things it needs to do and think, reasoning around whatever needs to be done. But most importantly, also, we need to also look into the human interaction. So what we call human in the loop. What that means is even though we can have an environment where our agent can thrive as an autonomous entity, but sometimes what happens is that we need to include a human, because remember, we're still using large language models and they can be a little bit unpredictable at times if not grounded well. And so this depicts everything that an autonomous agent would look like or would do. So we have the large language model call. It can do an action into an environment, a certain environment, doesn't matter what kind of environment really. And then there's always a feedback to say, okay, whatever happened here, well, I'm going to pass the feedback back to this large language model. And at some point, the large language model can stop if something went wrong or if it's time to stop because it's done everything it needs to do. And of course, this decision can be influenced by a human, what we call human in loop. This is one of the best resources when you want to learn how to build effective agents moving forward. And it's an important thing, again, to keep in mind. Anthropic is one of the leading AI companies in the world, so they know what they're talking about. If they are talking about agents and how agents should work and how to build effective agents, then we should all listen because they know what they're doing. So much so that they actually use these concepts, these workflows, these paradigms when they build their own agents, when they build their own agentic flows and systems. Okay, so there's much more here, and there's a summary of what's going on, and I will encourage you to actually take this article and read and learn from it. So you should keep it somewhere safe and refer to it whenever you need to refresh your mind. So this is what I have for you today. I hope this was helpful. Thank you so much for your time. Until next time, be well.